Okay, so hello and welcome back to another Unity tutorial in the roguelike series. This one will be showing how to import sprite sheets, slice them up, and add them to animations so that we can control the character's direction of movement with, with the animator, and then we can have it so that when you move up, it changes to the right sprite, and so on. And when in this video, I won't be going over like running cycles and walking cycles like for the direction. I'm just going to make it change the actual sprite depending on which direction I'm moving in, because that's enough for this one video. So for the next one I'll show how to do like different animations if we're walking or running in a certain direction and so on. So if we go into Wizard of Legend, the way their movement works is by default, alright, you got a sprite still facing down. If I press down, we walk down, but obviously I'm not gonna do the actual animation this time. I'll just make the character move down and like face downwards. And if you press up, obviously it goes up, left and right. And how this works is if I hold right and then press down, okay, that was in the way. If I press left and press down, I still have the same sprite for running left, even if I press up and down. I still have the same sprite on, whereas if I run down without holding the directional keys, it's down. If I hold up without holding directional keys, it's up. But if I press down and right, it then changes to the right sprite. So we've just got to keep that in mind if you want to make it just like this. So like, even if we're moving up or down, we still want to use the left or right sprite depending on which one we're holding. We only want to ever use the down sprite if the only key we're holding is down. And we only want to use the up sprite if the only one we're ever using is up. Just keep that in mind. So let's get into that. Let's close the game. And, might as well close Steam while I'm at it. So, first of all, I will leave a link in the description to the sprite sheet I'm going to use. It's a 4-way sprite sheet. I got it off an old YouTube tutorial thing I watched by Heartbeast, who did games in, Game Maker 2D games, and he put these sprites out to use. Don't use these sprites in your actual game if you're going to be like releasing it, but I'm just going to teach you how to use it for like the sake of testing. So here I've got a folder, RPG sprites, and I've got the 4 different strips for down, left, right, and up. So I'm going to import them all into Unity. And I might as well make a folder while I'm at it for sprites. Put them all in here. Now, when you get a sprite sheet in, it might by default be, default texture type on here. You want to change that to sprite 2D and UI. So then this weird black space around it goes. So you press apply, it'll go. But currently this is just like treated as one big long string like texture of characters. We want to split it up so that each separate thing is split up. So if you go on here, let's make sure we've got them all selected so we can do it all at once. If you click on sprite mode and change it from single to multiple, it's now going to treat it as, multiple sprites. But it doesn't know where they are different. So basically, if you click sprite editor, here's the sheet of sprites, the sprite sheet. At the top, you'll see slice. Now you can leave it on automatic and press slice. What it's going to do is it's going to get like a perfect cutout of the character and use that. But since we're going to be animating it so that like this is all on the same level, the sprite looks like it's moving up for the sake of walking, but it's still on the same level. We don't want to rely on the height of this. We want to basically use a full block here. We want all the size of each sprite to be equal. So if we click on here and change it to grid by cell size, and if I remember correctly, it's 14 by, I could count, it's not 14 by 18, is it? Is it? That looks about, oh no. So 14 long, but it's at 18, like 19, 20, 21. That seems about right, yeah. So if I click apply, we'll know quite soon if this is wrong. And then I basically have to do the same on here, but it also defaults it so you can just run in, press slice, apply. Now that does get the whole thing. Yep. As you can see, that line in between them is like the exact same place, so it's perfectly split them. If you're using a different sprite sheet, you'll want to just get the size of each sprite and use that instead of 14 by 21. But if you're following along with me, then obviously use these sizes. And on the last one, just do the same thing. And now it treats these images as separate sprites. So here we go, we've got them all. Now if I go into here and quickly create a player, so player, and let's just put it back to 0. And I'm going to add, we need an animator, and a sprite renderer, because obviously this is 2D. So instead of having a mesh renderer, you use a sprite renderer. And we're just going to give it a default sprite to use when it's like idle, so we'll just use this. And here he is. Now, you'll notice there's a problem, because it's a very like low resolution image, it goes really blurry, and obviously don't worry about that. What we just need to do is, on these sprite sheets, just select them all, and on the filter mode here, we want to change it from bilinear to point, which is no filter. Press apply, and then it goes to the normal. It looks better, basically. It doesn't have any weird filter on it. So let's just... So for some reason, this is all like centered in the scene, isn't it? Oh, maybe it's because the camera's slightly off-centered. That's a bit better. I think it's a bit off to the side, but it's fine. Now, all that's going to do when I press play is just, you know, stay there still. We've got an animator, but there's nothing on it. So we need to add animation. So we'll just make a folder for animation. And for the sake of this video, I'm not going to go making loads of subfolders. I'm just going to go for a player controller. So player movement. I don't think I'll ever use a different controller on him, but I'm going to just leave it on that. So drag that in there. And now obviously down here we've got our player movement substate machine here with what animations go to what. So now we can start making animations. And with sprites, the way you make an animation is, so you see here, you would select them all, right click, and then click animation, and it makes the down walking animation. But for this, we're just going to be doing idles, and since this sprite sheet doesn't have an idle state with like the character kind of just sitting there like breathing, kind of bobbing up and down a little bit, we're just going to use the default facing directions as idles. So what we can do is we can right click here, click create, just on the first sprite, and then call it like idle underscore down. On here, we'll do the same. We'll go create animation idle underscore left. And obviously, like, just quickly do it on the other two. So we get idle underscore right. And on here, we'll take this one and go idle underscore up. And now we've got these animations. Now I'm just going to go and put them in the animation folder. And on here, on the state machine, we're going to drag in idle down first to make it the default state because we're facing down. But we want to also be able to change to, let me just make this window a bit bigger. We want to be able to change from down to up, right, and left. So let's put this down here. So basically, with a state, if you've never used the animator before, how a state machine works is you have to give it all the possible ways to get to each animation. So if we started down, we want to be able to go to right, and up, and left. And also we want to be able to go from left to down, up to down, right to down. Basically, in this case, we want to be able to go from everywhere to anywhere. So I've done down to everywhere. Now we just need to get right to everywhere. Let me just give myself a bit more space. So I've got right going everywhere, down going everywhere. Now I need up going everywhere, which it now currently does. That's actually done now, yeah. So what that means is no matter which idle state we're at, we can actually go to each of the others, but it doesn't know when to go to them. Now, one thing is, all of these idle states can loop. If we, so basically select these and enable loop time, which just means that when the animation ends, if nothing else is going to happen, it'll replay it again. So obviously, if you're idle facing down and it ends the animation, you want to keep facing down. So obviously now if I press play, it won't do anything, but you'll be able to see on here visually how it works. So obviously we're just going to be playing the down state. Now actually, because I'm an idiot and I haven't, by default, they have exit time. And what exit time means is that after the animation's finished, it's going to go to the next one. We don't want that. Now, as far as I know, you can't actually select, okay, you can actually select like all of them at once. So if I just like go and select all of them at once and just turn off exit time, because there's not going to be any exit time at all. Okay, it didn't actually change it for all of them. Did it change it for any of them? Oh, I only changed it for that one. Well, okay, this might be a bit of a pain, but you want to... I should have done it as I was adding them, sorry. But you need to go through regardless and turn off all the exit times. If I haven't done any, then it's going to become obvious when I go through them later. So obviously, like, now we've got no exit times. So if I run it, it should just stay at idle now, idle down. So in player, yeah, it's going to keep looping idle down and not do anything else. Now, before we actually go into changing which way they're facing, we should also like actually make the character movement. So what we'll do is we'll just for now, well, we'll add a box collider for the oops, sorry, we're using 2D, so we want a 2D box collider. If we go into scene view, you'll see it easier how it fits. That seems okay, though we actually don't want it to be like that, to be honest. We kind of want it to be around here of his like lower body, and that's so that when he walks up to a wall, the wall doesn't stop at his head. He needs to be standing in front of the wall. Depending on the perspective of your game, this will be different. So I'm just gonna shorten the Y to 0.0 985. I don't know. I'm just trying to get this right. 0.1. Well, the width should be the width of the character. And we just need to offset it on the Y down to his feet, basically. There we go. I think that looks alright. That's not really, it doesn't matter at the moment because there's nothing to collide with anyway. I just thought it's good to get that in there. You could also map your sprite perfectly if it's like a projectile, but for the player, we just want it simply like that. Now, what we need to do is we need to add a script to the player for his movement. So we'll just get like player movement. And that is going to be here. We'll sort out scripts folder and whatever. You can do your own folder sorting, and I'll do it in my own time maybe, so I'm not sitting here doing it in the video. But generally you want folders for scripts, folders for this, folders for that. And then I should also put the... Well, I don't know why I have an idle animation here doing nothing, to be honest. I think I made that before the video when I was just testing stuff. Don't need that. Okay, so in Visual Studio, I'm zoomed in from my last tutorial. Anyway, let's just take this out and start from scratch. I always like starting from scratch. So, one thing we want is, the only parameter we want really is a way to control the speed of the movement. So we'll just have a public float speed. And we'll have a default of, actually I'll just leave it blank. So what we want to do is, we want to have in the update function, so void update, we want to run multiple functions for doing different things. It's not nice to have all of your code in an update. It's nice to have a bit of code in update that calls other functions, because otherwise it gets really messy in the update. So we're going to simply have, well, one for moving. Whoops. It doesn't exist, so it's not going to like me doing it, but I'm going to do it anyway. But before we move, we want to know how we're going to move. So we should take, we need one for like taking in input. So like take input. And then we are going to make these now. So we'll take move. Whoops. So this is going to be a, not a public void, which one? Private void move. And then a private void take input. So now we've got these two functions. It's going to run this every frame and then run this. So this is for knowing where we're going to move and all this other stuff. So we want a private, because this isn't going to be controlled. We want to know which direction the player's facing. So usually you would use vector 3 to know about the movement and position, but we're going to be using vector 2 because this is 2D. We want to know the direction. Now, one way you could also do this is you could take an enum, which is basically a state of like whether the player is currently up, down, left, or right. The only problem with this for what I'm doing at the moment, I might change how I do it in the future in upcoming videos. The problem is I'm going to be taking the actual vector 2 and using it as a number, whereas enums aren't numbers, they're just states. So we'll just stick to this for now. And we're going to say, well, every frame direction is 0. But you can't just put 0, it's a vector 2, so it's vector 2.0. Which basically, vector 2.0 is just like 0, 0. Obviously, it's a vector 3, 0 would be that. Because it's, normally you would have x, y, and z, but in 2D, you only have an x and a y. There's no depth. Well, there is, but it's all to do with layering rather than actual depth. Now, after we've done this, we want to take input. So we'll say if input.getKey we want get key, not get key down, because get key down would only do it on the frame I press the button, where we want to check every frame what button they're pressing and like which which button they're pressing. Now obviously if they're pressing like 2 buttons at once, then that's gonna be a bit different. I will show you that, but for now we're just gonna do get key code dot, and we're gonna start off with up, which is W. So if we press up, we want to do this. If I'm just gonna copy and paste this. So I'm gonna say if this, if this. So WA. Obviously, you can put your own control set. We'll also do a thing in upcoming tutorials where I'll show you about key bindings rather than using hard-coded controls. Though I think even in Wizard Legend they're still hard-coded to WASD. But if I'm wrong, I mean I can still do how to change key bindings anyway by using the input manager. But anyway, so once we have got this, we want to then let's just take this first one. And we're going to say, well, if we press the first one, if we press W, we want to say direction, which is a vector. We're going to add vectors. Vector2 dot up. Normally, up would be, in vector3 would be up in the Y, which would mean going up into the sky. In this, it's still up in the Y, but because it's 2D, it doesn't mean like coming off the ground necessarily. My game's not really going to have like depth in terms of the ground, because you're always on the ground. Now let's see what happens if we press play, assuming that I've not done anything wrong. Though, first of all, we need to set a speed. So, speed 5, I don't know how fast that is. Okay, it's not actually moving the player, because I'm stupid and I haven't actually done move. So, transform.translate, translate. And now we need the direction to know where to go. We need, well, it's times, not comma. We need to know how fast to go, so speed. And then, since games and update in general is based on frames, so like let's say you have more frames and you run this code now, you're going to move faster if you've got a better frame rate. So the way you can counteract this is by using time.delta time, which, without going into what it actually does necessarily, it's just a value depending on the last frame, so that if you're laggy and you're holding on the button, you're still going to move as far as you would if you had a good frame rate. As you see, it says the time taken to complete the last frame. So if you had a really long frame because it was laggy, you're still going to move the same distance. So it's a really good thing for consistency. So now that I actually have the function to move, if I press W and set my speed, there we go, I'm up. And now let me just set my thing to minus, so I'm back. Alright, I need to definitely tone this number down to like 1 maybe. Even less than that, like 0.5 maybe. Let me just set it actually to positive again, because I'm now on the screen there. Yeah, I'm going to set it to about that, just for now. I'll set like, the default can be like 0.5. Now, I've only made an up, so I'm going to go through and do the rest of them. So we're going to say the direction here, 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 and obviously it's up, A is left, S is down. Whoops, I pressed compile. Nope. And then D is right. So now, give it a second to compile. Now, as you see, as I press the different buttons, we are moving around. See, the reason why I can go diagonally, even though I'm saying just checking WASD, is because if I hold W, it's adding a vector 2 up, and if I press right, it's adding a vector 2 right. So it's going to go, well, X is 1, Y is 1, or in this case, Y is 1, X is minus 1, and it's going to go left and up. So that's another thing to note. Now, with 2D games, one thing people don't really realize at first is that a character actually moves faster if you're moving diagonally, because you're going to be moving up and right at the same speed as if you just, like, if I press up now, I'm going to move slower than if I'm pressing up and right. Even though it's in a different direction, I'm still moving faster. And obviously, I'll go into balancing and all in the future. This is just simply like how to set up movement so you can get going yourself. Now, what we want to do is we want to make it so that depending on how we're moving, we instead go to different like animations. And we've already set up the kind of state machine for the animation. but we need some way of being able to actually go between them. So what we're going to do is we need to go into our code, and we're going to make another function for basically, let's go to the animator, So here it is. In animators, you can have parameters, which basically control how it works depending on different things. And in a very simple one, you might have an animator where you have an animation that gets triggered. So like, you'll set a trigger and then it'll do that animation, and then the trigger will go off. Or you'll have a boolean where like you set something to true and you want an animation to happen while it's true. Now we're going to use a float, which basically we're going to have a number input for the like x direction and the y direction, and this is basically going to let us know which direction we're moving in, so that the animator knows that like if our x direction is positive, we're going to be moving upwards, and if it's positive and the y is negative, blah 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 blah. This is basically going to control all the different things. So we need some kind of function here for controlling the movement. So we're going to say put a private void, and what should we call it? Well, we're just going to say like set movement. I might just put like set animator movement. It's going to take in a vector 2, which is the direction, and then this is going to take. Now we need to here we go. We need to let's see how we've got a code. So on our player, we've got this code, and we've also got the animator, so we can reference it directly. So if we have a private animator, and we call it animator, and then the void start, we then say the animator is equal to get component animator. This basically means that we've got a variable animator, and we're going to set it equal to, and then get component animator basically finds an animator component on the object this code is on. So this code is on the player right here, and so is the animator. So if we just get component, it's going to refer to this. And this has float in the parameter. So if we now go back down here, we can say animator as our variable dot set float, which is a thing for animators. You can also set trigger, set bool, set int, but we want to set float, and then it takes in an ID and a value. So the int ID isn't actually an int in our case, so you can see the other ones that are string or whatever. We're going to be using a string, and we've called it x direction. And then we want to set it equal to the direction. But the direction's a vector 2, and we only want the x, so we're going to say direction.x, which is the x component of the direction. And then this is, whoops, didn't mean to duplicate it to there. And then this is going to be the y component, and it's wider. Okay, so now, what this basically means is that we can now change the, let's see, where is it? We'll do it up here in the move. So after we've started moving, we can run the animate move. Oops, I can't type. What do we call it? Let's call it animator movement. There we go. And it takes in the vector 2 direction, which is public variable up at the top. Where's direct? There it is. And now, if we like go down here and print, can we do animator.getFloat, and then we'll take in extra, for example. So if I run this and go to the console, 0, 1, -1. 1, -1. If I hold both, it goes to 0, so we're not moving. So now it basically this knows which way I'm moving, and obviously I could print the y as well. I just didn't bother, but you know. So now we're changing the parameter inside the thing here. Now with a state machine, we currently just have like different idle states, so we're not going to get too complicated into having walking and running animations, and then all the other animations. So what we can do is now we can say how we want it to change. Now this might be a little time consuming. Obviously, if you know what to do from now on, you can kind of go yourself and do it. So we want to say, like, from idle to right, we want to do it when the x direction, well, just think about it. So if the x direction is greater than 1, well, sorry, greater than 0, so then we'll go right. But we also want to make sure, let me just think from the, no, that's fine. We just want the x direction greater than 0 to go right. And then to come back to down from right, we just want to be, the x direction to be 0. Can we not have we want the x direction equal to 0. Well, I could just say we want the y direction. So we've got wider. To come down, we want the y direction to be less than 0, because as far as I remember, well, let's just see what happens now. If we go right and then down, right, down, right, down, right, down, you see? So obviously up and the other ones don't work yet, but we'll go right, down, right, down. So now we actually animate properly. We also want to, this will make it a lot smoother. I actually forgot to go onto here and say we want the transition duration to be 0. Now if it's gonna be the same for all. So for the rest, since this video is dragging on, and I'm sure you can do it yourself now if you've been watching along, if you haven't quite understood it, I'll show you the finished thing in the next video. You should first of all go through all your little transitions and turn off fixed duration, and set the transition duration to 0, so that there's no like weird movement delay. So like if you see now, I go instantly right and down, it works fine. And the other thing you want to do is you want to set up all these so that they change when it's right. So think, if you're moving right, the x is greater than 0. If you're moving down, the y is less than 0, because y is negative when you're moving down and positive when you're moving up. X is positive when you're moving right and negative when you're moving left. So I've shown you how to do it on these two. So obviously we go to the right when the x duration is greater than 0, but we come down when it's less than 0 on the y. So I want you to do that for the rest of these and set up your character movement. Now, you should really be able to do this on your own, otherwise I'll just be sitting here wasting loads of time. This video's already gone to 28 minutes. So I'm going to leave you with this as a task. Now, obviously I'll make a new video in like 2 days probably on it, so if you do get stuck, then I'm sure you could try and figure it out yourself, but if you really need the help, then just be patient. So the quick things I want to say is, obviously, if you want to see more of this series, then subscribing and liking would be lovely. If you want to join our Discord to discuss Unity in any way, or any other engine or language or whatever, just coding related, game related, feel free to join. The link's in the description. I'll also link to this sprite sheet so you can follow along if you don't have your own already. There's in my server this weekend, we're going to be doing a 2-day game jam. I'll pick the theme with a random generator on Friday night, and then you have Saturday and Sunday to make the game, submit it, and then me and the admins will vote for a game, or the top 3 games, and we'll showcase them in a video next week. So anyway, if you want to take part in that, obviously it's completely free, and just, you know, come along and enter it, be part of the community. But anyway, this video is getting on very long. I don't want it to take forever to upload, so thanks for watching, and goodbye.